Okay, so today we are actually going to start in our new physics unit. Yesterday you got started with the bell ringers. Today we're actually going to get into introducing and starting this unit. So our language objective is I can reflect on and predict what will happen in 4 physics scenarios using video demonstrations, focus notes, setup, and sentence stems. All right, so our agenda as it states, we're going to go through, I'm going to set up some notes with you. You can pause the video. I'm not going to spend too long on it, but I know you're going to need a little bit more time. So pause the video. We'll go through 4 different demonstrations, jot some notes down on each of them, and then you're going to take a picture of your notes or screenshot it if it's on Notability and upload that to Google Classroom. Well, let's get going. All right, so I kind of told you that we were taking focus notes today, and that's kind of true. But really we're just doing that focus note setup. So up at the top of your paper, and again, this can be paper done in Notability or this can be paper that you have just around your house. As long as you don't lose it, if you brought a notebook home, put it in there. It doesn't even have to be your science notebook. Just put it somewhere. Okay. So we are going to call these our Intro to Physics demo. And demos, again, is short for demonstrations. Okay. So basically, we're going to watch 4 different demonstrations because we can't do them in class as like mini labs. So yeah, we're going to watch videos of them. I have the whole setups recorded, whole videos parted recorded. But we're actually going to go ahead and we're going to take our box. I didn't mean to keep writing in red. I thought I switched back to black. There we go. We'll just undo that one. And we're going to divide it into 4 quadrants. Something kind of like that. If you are somebody who you're a big writer, like you write really big, you're welcome to do these on 4 separate Notability sheets. Okay. Or on 4 separate sheets of paper. However you want to do this, we are going to be sketching and drawing in each one, as well as writing a little bit. So whatever you need to make it make sense and make space for you. So 4 quadrants. Okay. And you can number them if you'd like. 1, 2, 3, and 4. And those numbers are going to correspond with these 4 ideas up here. I am not feeling the lightsaber today. Let's go with an arrow. Okay. With these 4 images, and then the next 4 like slides sort of are what's going to go in each box. All right, so we are going to start with number 1, the flying balloon. So each of our stations, because this used to be an actual station lab, have 4 parts. Number 1 is going to be discuss. Number 2, draw in your notes. 3, discuss and draw. And 4, discuss again. Our last number 4 is actually going to be kind of a write. This is why I suggested if you have someone who writes really big, you might want to do this on a separate sheet of paper, each one of these on a separate sheet or on a half sheet, so you give yourself more room. My example is something that I write very small, so this would be how I would do it. But again, if you are a big writer, feel free to move to a bigger space for each one of these. Also, on the note of our discuss for each one, because we are in this online format, if you would like to discuss with someone else in a private messaging part of WebEx, you are welcome to. So I will let you set those up if you would like. And if you are somebody who's like, nope, I just want to get it done, I am just going to worry about doing it here with me, then by all means do that. And your discuss is just going to look like more of a think about, pause the video, try and process why it's happening the way it's happening. Okay. So first one, flying balloon. So I'm going to make the video bigger. Much bigger. And I'm going to leave our diagram of stations up here so you remember what you're looking for. All right, I am going to show you the lab demo setup for number 1, the flying balloon. Again, I know it's backwards, I'm sorry. So first things first, I have a bright yellow balloon, this time without a hole in it. I have some masking tape. We come over here. Find me, come on, find me. There we go. I have a white string all the way across over to this board here.
I also apologize for the audio.
On the string, I have a straw, just part of the straw. They're the same straws we were using for our earthquake shaped buildings, but without the bendy part. Okay, so I am going to, first, inflate my balloon. I apologize for the audio quality. I did not realize that the microphone that I was wearing around my neck was hitting the lanyard until after I balloon is inflated. I'm going to take a little bit of masking tape. And I am going to attach my balloon to my straw in 2 spots without potentially popping the balloon is our goal. Now this is Mrs. Beetle not being a very good lab demo. Okay. My arm is in front of the balloon. So here's our balloon. Here's our tape, straw tape to it. And I know that this is a little bit of an incline, but we're going to watch what happens. And here we are, left with our balloon, sad at the end. All right, so at this point we have watched the video, we've watched the demo. Step number 1, discuss what parts of the device affect its motion. I'm going to do this one as an example with you and talk you through all of the parts. And then from here, you're able to go ahead and do them on your own. So number 1, what parts of the device affect its motion? I noticed that the string affected its motion. Keeping it kind of in a straight line rather than going everywhere. And then obviously the balloon, ooh, typo there, quick erase. Oop. The balloon affected its motion as well by pushing it forward. All right, so in my notes, I need to draw a diagram of the device that shows these components. So I'm going to start with my string. Okay. I am going to draw in my straw. Again, I know we're not artists, but we do need to make sure that we are using the best scientific diagrams that we can so that we are being accurate. And then there's my balloon. And then this is going to be the tape to the top of it. A good diagram might also have the labels on it. So I might say string and balloon, straw, and tape. Again, I apologize. I know the writing is not great on here. I am in the works of getting one of those little styluses, not the fancy expensive ones, the cheap ones. All right, so we've done the discuss, number 1. We've done the number 2, drawing the diagram. Okay. Number 3, what are the forces acting on the components of the device that influence its motion? So if I'm thinking about the motions, what is forcing it to go one way or another? So I am thinking, okay, I'm going to use a different color, that the balloon is pushing air out of it. So that would be air. And as it pushes the air out, the balloon goes forward. And then I'm also thinking, I said that the string had a role in it. The straw is keeping the balloon from going everywhere. So I'm thinking that the straw is kind of keeping the motion within here to go forward. All right. I know it's not going to be perfect. This is the first time we're looking at these diagrams, and we're going to come back to them. So it is important that you don't lose these, as we're going to build on these diagrams as we go through our unit. And then finally, number 4, discuss, how does this device work? Use the diagram as a model to explain your ideas. All right, so this device, I am going to switch over to typing because you will be able to read it rather than what I am doing right now. So I'm going to decrease my font so you can actually see what I'm writing. So this device, what was the question? How does the device work? This device works by pushing the balloon forward as air comes out the other side and the straw keeps the balloon going in a straight line. All right, so there's my number 4, explaining how this thing works. I'm gonna move this one over, and you are obviously going to be able to see these all the time. Oh no, I didn't mean to duplicate it. Undo, undo, okay. But I will go ahead and post a more finished version of this as well as your example. All right, you guys are going on to number 2. All right, station number 2, floating magnets. Same questions as before. Discuss, draw, discuss and draw, discuss. Right here, down here in the bottom for you. And then here is your next video, floating magnets. This by far is, if you remember the towel demonstration, this is right up there with really cool science demonstration. All right, so right now I am showing you the setup for, I know this is backwards. I'm sorry, I don't know how to fix that. For number 2, this is the floating magnet. So right here I have a small plastic simple test tube, and I have 2 magnets. Okay. So if I can get the camera to focus here for a quick second. Okay. These magnets have an N and an S on them, showing you north and south. N would be when you're looking at the
You can go ahead and make a prediction what you think will happen when I put different ends together.
Okay. But I'm going to go ahead and start my setup by taking my plastic tube. I am going to put my north end down and drop it in. And then I am going to put my south end down. And let me move my hand out of the way so you can see what's actually going on. And you can see that my magnets are floating. See, the magnets are floating. All right, so that was the floating magnets. I did tell you it's about as cool as those towels I did last unit. Okay. So number 1, discuss what part of the device affects its motion. So when we are talking about the motion right now, we are talking about the magnets that are floating. Specifically that one on top that is quote unquote floating. You're going to draw this in your notes, diagram the device, all 3 parts please. What are the forces that are acting on the device? What is keeping that magnet? What is forcing it from falling down? And then how does the device work? Please use your diagram as a model to help explain your ideas. Number 2 is the air-powered car. So I'm going to show you one video for the setup, and then it failed miserably. And so I took the car home and I fixed the little propellers and put new batteries in it, and it works a little better now. So video number 1, keeping in mind, these are the things that we're looking for. All right, I know this one's kind of hard to see back there, okay, but this is number 3, the air-powered car. Number 3, the air-powered car. So in front of me, I have a small monster truck, I have masking tape, and I have a little battery-operated fan. Okay. All right, so the setup is as follows. I take a piece of tape. I am going to take my fan and put it on the top of my monster truck, and then I am going to simply tape it down. So I am attempting to tape my fan to the top of my little toy monster truck. And this is why I will never have a career as a vlogger, because I cannot show you what I am doing as I'm recording it.
so you don't have to worry about me being a famous YouTuber someday.
All right, so now all that's left to do is to turn the fan on.
Cool.
All right, so like I said, the video did not work, and so I took the little toy car home and found out that somebody put the propellers on the fan on backwards, put in some new batteries, and here is our fix it. Okay, so this is trial number 2 with the fan blades actually on the right way and new batteries. All right, so there's the actual demo and the setup. I've showed you all the parts. Now go ahead and I'm going to have you pause the video to do steps 1, 2, 3, and 4. Discuss what parts of the device affect its motion. Draw in your notes the diagram that shows all those parts together. I told you all of the parts in the first part of the video. Number 3, what are the forces, acting on the components of the device that influences motion? How are the forces pushing the car forward? And then finally, how does the device work? Write it out, explain it. All right, last demo is our magnetic cannon. So I'm going to go ahead and remind you one more time. We are doing steps 1, 2, 3, and 4. And let's go ahead and get the setup underway for this one. Again, 2 parts, different camera angles, all the fun of learning from home. So this last one is demo number 4 on our science demos list. I am going to have to flip the camera around so you can see. Nope, not an option. Okay, so I have 2 meter sticks. I have a handful of these little metal marbles. And then we're supposed to have 2 super strong stick magnets. However, we couldn't find those at the school. So I am using these little bitty, they're called buckyballs. They're like tiny magnets, and I have formed them into a stick. Okay. All right, so there is that. Now we're going to see what actually happens in the demo. This is one that if you have any sort of magnets at home to try this out, I would absolutely love if you included those videos. You have a slow-mo feature on your iPad. Record those, upload those, send those to me. Those are going to be super useful as we get going in the future, and this is an easy demo that you can do at home if you have access to magnets of any kind. All right, so I'm going to try to record this from a couple different angles for you, but essentially our setup is we're going to set it up down here and then flip it to the other side. So we have our stick magnets with one of these little metal marbles. I'm going to put another 2 down on that side, so we have a total of 3 right there. And then all these meter sticks are to keep the marbles from running off the counter. And then I'm going to have 1 marble right here. So you are trying to figure out what happens when I push this marble down into the list of other magnets. All right, so here we go. These are the joys of online. Okay, I'm going to do one more, but from the opposite end. So, I have that same marble stick setup. I'm going to put it down here, and this way it is going towards the camera this time. 2 marbles down here, so making 3 total. And then here comes that other marble. We'll do it one more time. This time I'll do it with 2 marbles and 1 marble. All right. Okay, so there's your magnetic cannon. This is one that when we get back in the classroom, I'll actually have you guys do a bunch of demos with yourself so you can play and experiment with them. And again, this is one if you have magnets at home that are open-ended or magnetic marbles of any kind, these would be fantastic for you to try out. So, number 1, going through back on your note sheet,
discuss what parts of the device affect its motion. So remember, we have the little magnet ball marbles, or the magnets that are all clumped together, those buckyballs. We have the marble metal balls, and then we have the 2 meter sticks, which are really there just to keep things in line so they don't fall off the table. And again, so if we're thinking about what affects the motion, the magnetic marbles and the little magnets are going to be more affecting of its motion than the meter sticks. Step 2, draw it out. Show me a diagram in your notes as to what this setup looked like. And then go ahead and draw on those forces that are acting on the device that influence its motion. And then finally, how does this device work? Give me 1 or 2 sentences. How does this work together? Why are things moving the way they're moving? Go ahead and sum that up. All right, we have reached the end of our lesson today. Last thing is just for your attendance today, you are taking a picture of your notes or screenshotting your notes depending on how you did it and turning it into Google Classroom. So without further ado, thank you so much. Tomorrow we are going to do something a little bit more fun, a little bit different. I'll actually post in BB9 tomorrow with just our fun little intro. So have a good rest of your day. Remember, this is how you're getting attendance done today, is by sending in your completed notes. And yeah, I'll talk to you guys tomorrow. Bye-bye.